Okay, our first venture into trig, we're going to just start with radian and degree measures. You know what degrees are? Yes? You've used them. We will talk about what radian means and what it's made up, and what does radian, the word, remind you? What other geometry word? Do you know what radiant means?
Nope.
Okay.
But is that the word?
No.
Oh.
Radius, yes. And it is linked to the radius of a circle. Okay, so that's how we get a radian. It is actually the radius of the circle, okay, which is straight, correct, measured on the circumference of the circle. So that's actually what it is, and we'll talk more about that, and we'll use it in a different way. The biggest thing is you need to understand the difference between the two. It's not that big a deal. So first of all, so you know things about an angle. We obviously have a vertex, yes?
Yes, we do.
And you've seen angles your entire probably school career in different forms, but now we're actually going to talk about an angle as a movement. Okay, it starts on the initial side. I will usually say ray. The book says side. It starts on the initial ray side, and then it moves from there. So actually, what you're seeing is one ray with its starting position and ending position. So it started on the initial and ended on the terminal, which means terminate. You notice it is moving up. This is a positive angle. And we use theta, circle with a line through it. It is a Greek symbol to name an angle. Generally, we use theta, beta, alpha. We usually stick with those three. Beta is just a B with a long. Alpha. There you go. Wrong direction. Alpha is just like little fish. Theta, beta, alpha are all just names of angles. They're a variable for an angle. Okay. If I rise to get a positive angle, that would be counterclockwise, correct? How do you think I get a negative angle? Clockwise. And this is a negative angle. And we will, again, you'll see this again. These arrows are important because it tells you whether it's rising. Think about it, rising would be positive, falling would be what?
Negative.
Negative.
Because negative, you still use theta?
Yeah. You just, everything would be the same. We will use theta for most everything we do until we start and putting, like, if we have three angles unknown, then they'll do alpha, beta, theta. It's never a B. If you think it looks like a B, it has a longer. Yes.
Which one is theta?
What?
Which one is
Theta.
Is it the circle?
Yes.
Okay.
Theta is the circle. Beta looks like a B. Alpha looks like an A. Am I good?
Yeah.
Okay. The vertex of an angle, you know what a vertex is, correct?
Yes.
Okay. So standard position, we will try to put angles in standard position as much as possible until we put them into real world situations, but then we still put them in standard position with an imaginary coordinate plane because it makes it easier to deal with. Because then we have quadrants. Okay? We name quadrants first. Oops. I'm probably jumping ahead of myself, but it just seems natural to talk about here. Quadrant 1, and we put Q. For what? Quadrant, and it is a Roman numeral. I will not accept an English one. It will be wrong. And then we go quadrant 2 because we are going positive direction. And then we go quadrant 3 and quadrant 4. Okay. Standard position, that's what the slide is about. The vertex is at the origin. And an angle is all about where it terminates. This angle terminates in quadrant what?
3, 2.
2. Quadrant 2. What do we know about quadrant 2? What kind of an angle is that?
Obtuse.
And it is obtuse. It is larger than 90 degrees, yes?
Yeah.
Probably less than 135. What would 135? That'd be half of it. Right? It'd be 90 plus 45.
Yeah.
Okay. When we sketch angles, you just need to have them in the right quadrant. Make sense? I would not put a 170 angle close to 90 degrees. That would not be correct. So you just need to be a realistic guesstimate. And again, if I rise, it is a positive. If I fall, it can be in standard position as well, can't it? This is a positive where it rises. This is a negative when it fell. But they could still end up in the same position. Which one's bigger, the positive angle or the negative angle in absolute value wise? The negative. Because the one that's positive went through quadrant 1 and part of quadrant 2, right? So that's a little bigger than 90. The one that fell, well, it's bigger than 180, isn't it?
Yeah.
Yeah. So pictures are going to help us a lot in trig to know where we're at. I already talked about positive and negative rotations, clockwise, counterclockwise. I already talked about alpha, beta. They're just Greek symbols, alpha, beta, theta. Uppercase letters, very rarely. If we're in a triangle, we will use uppercase, like English letters, A, B, C. If we are in the coordinate plane, probably not going, theta is going to be your go-to. It's like you put X for everything, you're going to put theta for everything. Sound good? Coterminal. Well, we had a terminal side of a ray, didn't we? A terminal side of an angle. What does co mean? If I'm co-presidents with somebody,
With something,
I'm sharing it, right?
yeah.
So what does co-terminal mean?
Sharing
They're sharing what?
the terminal.
The terminal ray. So on this picture down here, alpha is in the third quadrant, yes?
Yeah.
And beta is also in the third quadrant, but it is negative. Do they terminate at the same place?
Yeah.
Yes? So alpha and beta, they're called co-terminal angles because they're sharing what?
A terminal.
The terminal side. What do you notice about alpha and beta? What's their sum?
360.
360. Wouldn't they have to be 360?
Yeah.
Okay. What happens if I put another angle and I went like this and stopped right there? Would that be coterminal with it?
No. Yes.
Is it sharing the terminal ray?
Yeah.
Yeah. What if I took this angle from here and went like this, and then like this, and this, and this?
Yes.
Is there any limit to the number of
No.
co-terminal angles there can be?
No.
No. On the second picture, you notice that one of these beta is larger than 360 and alpha is just in that first quadrant. They're still co-terminal angles, okay? So when you, I don't know how much of your homework you could even do. I think you could name some quadrants. I think you could name some co-terminal angles. Try it, right? See what you can do. If you can't do anything, we're going to finish notes tomorrow and go from there. Okay? We'll see where we're at. Yeah, because I think we got a good chunk of it, what you need for today.